Imagine a parachute with no fabric, no ropes, and no careful packing. Instead, picture a simple flat disc that, when dropped, magically transforms into a stable, inverted bell shape, guiding its payload on a perfectly vertical path to the ground. It's the reality of a groundbreaking new parachute inspired by the ancient Japanese art of Kirigami, developed by researchers at Polytechnique Montréal. The idea was born in the Mechanical Engineering Department at Polytechnique Montréal, where professors Frédéric Gosselin and David Mélenchon, along with graduate student Danick Lamoureux, explored the potential of strategic cuts in a material. They were fascinated by Kirigami, the art of cutting and folding paper to create three-dimensional shapes from a flat sheet. You might know it from making paper snowflakes. The team spent 2 years experimenting with countless laser-cut patterns on plastic sheets, searching for the perfect closed-loop design that would reliably deploy into a stable structure in mid-air. They tested their prototypes by dropping a weighted bottle from heights of nearly 200 feet, both in the lab and outdoors using drones. And the results were published in the prestigious journal, Nature. Traditional parachutes work by trapping air underneath a canopy to create drag. However, this trapped air can create large, chaotic vortices, which act like invisible gusts of wind, pushing the parachute off course. This drift makes accurate airdrops for things like humanitarian aid or drone deliveries incredibly tricky, as packages can land far from their intended target and become lost or damaged. The Kirigami parachute changes everything. Its secret lies in its hundreds of small laser-cut holes. As Professor Gosselin explains, the inverted bell shape stretches the slits of the Kirigami pattern and forces the air through its numerous small openings. This causes the airflow to remain orderly, without large chaotic vortices, resulting in a predictable trajectory. This orderly airflow is the key to its incredible stability. No matter how it's thrown, it quickly reorients itself and descends in a strict straight line with almost no drift, landing right on target. It's incredibly simple and cheap to make. Constructed from a single sheet of material, anything from a dollar store Bristol board to biodegradable plastic, it requires no stitching or complex assembly, just a laser or die cutter. This makes it ideal for mass production. Second, its potential applications are vast. From ensuring precise humanitarian airdrops of water, food, and medicine in disaster zones, to enabling more accurate and safe drone deliveries, and even carrying scientific sensors into storms. The researchers have shown the design is scalable, meaning its stable behavior holds true whether the parachute is small or large. Imagine a future where a fleet of these inexpensive, precise parachutes can be deployed from a drone, each programmed to land in a specific pattern, delivering life-saving aid exactly where it's needed. It's a stunning example of how ancient art can inspire modern technology, creating a simple, beautiful solution to a complex, real-world problem.